Alright, so in this lab here, we're going to be investigating several factors that affect reaction rate. The reaction we're going to be demonstrating here involves a piece of solid magnesium. We're going to be dropping it into various aqueous solutions of hydrochloric acid. How we're going to be measuring the rate here is we're going to take 1 centimeter portions of this magnesium ribbon here. Whenever this 1 centimeter portion is completely consumed, we're just going to take the total time for that there. Because I'm going to know the mass of this 1 centimeter increment, if I can divide that mass by the time, that's going to overall give me the rate. We've separated this lab here into 3 different portions. First portion here, we're investigating the different concentrations of hydrochloric acid from 0.5 molar, 1 molar, 3 molar, and 6 molar. In part 2 here, we're going to try to take this piece of magnesium ribbon here. Again, we would have ripped it up into 1 centimeter fragments here. We're going to try to play around with the surface area by trying to roll this piece here. Now this one here isn't overly strong, so if you make the curl too tight here, it sometimes does snap on you. I'm also going to take a pair of scissors and try to cut little slivers of this here, hoping to increase the surface area to see the impact in dropping in acid. In part 3 here, we're going to investigate the impact of having different temperatures. So I'm going to take my acid solution here, dropping it at 4 different temperatures, an ice water bath, a room temperature, one that's slightly warmer and one that's close to boiling, and see the impacts of reaction rate. So just to start off here, I've ripped off a piece of 11 centimeter magnesium here. I know I'm going to have 11 different reactions that we're going to be demonstrating in 1 centimeter increments here. I'm just going to weigh out the 11 centimeter piece first. So I'm going to record that down as 0.19 plus or minus 0.01 grams. Because I'm going to, using a ruler, measure 1 centimeter increments, I'm going to rip it into 11. You can take this mass here, divide it by 11, and that will be the mass per piece that's going to be dissolved. So see you again in part 1. Alright, so in this station here, again, we're going to be testing the different concentrations. So going from left to right here, I have 0.5 molar, 1 molar hydrochloric, 3 molar, upwards to 6 molar here. So that's just going left to right here. I have my 1 centimeter pieces of magnesium here ripped off already. I'm going to try to drop them in as quick as I can at the same time. Hopefully you'll still be able to see sort of the reaction going. You do want to note when the magnesium has completely disappeared. As I drop that in there, I'm going to try to start my stopwatch as well. So we're just going to time how long it takes for this reaction to occur. So let's go. Here we go. Six molar one's almost gone. Three molar one's gone. 1 molar one is still sizzling away there. So the 1 molar one is gone. Okay. All 3 of those were sort of stuck on the surface here. This 0.5 molar one here is actually, the piece of magnesium has actually fallen to the bottom here. You still see it's fairly cloudy here because the bubbles are still indicating that the reaction is still going on. Just gonna lift this up briefly so you can see what it looks like here. So our piece of magnesium is just sitting at the bottom of the test tube here. It definitely is still reacting away. Starting to look a little bit more clear, so we'll just wait till this last one here dissolves. We've chosen roughly concentrations that are double of each other. So 1 molar would be double of 0.5, 6 molar would be double of 3 molar. Nobody says the rate has to double, but that's one way to look at it here. If we have twice the number of particles, is the rate here twice as fast as it was initially? You can do a balance equation and figure out what the gas is being released here. When the concentration of HCl gets too low, we might run into even some limit excess kind of problems here. Maybe there really isn't enough HCl to dissolve the rest of the magnesium, so once it sort of stops bubbling, we can take a reading at the time. So look like bubbling is pretty much stopped. For all these times here, they may give us sort of minutes and seconds. Remember to convert it to a total number of seconds before you do any rate calculations. Thanks, guys. Right, so this is part 2 of our experiment. This time we're using the same volume, so 10 milliliters. I just chose the 1 molar, so we have a constant composition across our different trials. This time for the piece of magnesium, we're investigating the effective surface area. So one piece here I've left unchanged, it's still flat. One of them I've tried to roll up into a ball. The other one here I've cut into tiny little slivers here. Again, I'm going to do my best in trying to drop these in at very similar times here. We'll start the stopwatch, and then again we're recording the total time it's taking for the reaction to occur. So I'm just going to grab the flat piece here, grab the rolled. For the slivers here, I'm just going to pour them in using this piece of paper here. So again, let's go 1, 2, 3. So exactly the same reaction, but we're just trying to examine the effective surface area. So we have our rolled piece on the left-hand side, the flat piece in the middle, the slivers on the far side. All right, so it looks like the slivers are now gone. So the rolled piece is gone, and the flat piece is also gone. Thanks, guys. Alright, so this is part 3 of our experiment. We're going to investigate the effect of temperature of the hydrochloric acid. For each of the test tubes, I filled in, again, 10 milliliters of 1 mole hydrochloric acid. I have 4 different temperatures here. I have a cold water bath here, which is currently 4.5, plus or minus 0.5 degrees. A room temperature bath, which is 21. I have one that's slightly warmer here, so this one here is 83 degrees. And I have one that's in a boiling water bath here. This one currently is 96 degrees. I'm just going to pull these test tubes. They've been equilibrating in the hot water baths for a little while here. I'm going to line them up from coldest to hottest, and then I'm going to drop in our magnesium. So we have our cold water bath. I have one that's warm. This one here is slightly hotter. And our last one here, which is our boiling one here. I'm going to pick up our pieces of magnesium. Make sure these magnesiums here drop directly into the test tube. So here we go. 1, 2, 3, 4. And I'm going to start the stopwatch. Alright, so the one in the hot water is now gone. Right, the one in the slightly warmer one is now gone as well. You see that these two test tubes are clear. So the one in the room temperature bath here is also finished. Just leaving the one in the cold water bath here. Set that up so you can see here. we go. Looks like the cold water one's done as well. Thanks, guys.